Okay guys, in today's video we're going to replace the crossover cable that we used in the previous video with a simple Ethernet switch, a Netgear FS105, and we're going to go into its operation and the sequence of events of what happens when you connect to it. So let's get right into it. Okay, here we are. We're set up with Wireshark and Task Manager. And we're going to look at the sequence of events of when you plug in the computer to the switch. Now, with the initial plug-in, there is some electrical in the weeds data handshaking that goes on there, and it's kind of complex if you can do research on it. But basically, it's very similar to RS-232 or modems, or any of those kind of electrical devices where they just basically are sending some signals back and forth to get in sync with each other for the correct, essentially correct baud rate. So you want to have your speeds match, but they're not actually talking to each other with packets. This is strictly hardware type level things that don't get into the world of the packets per se, and I'll show you what I mean by that in just a second. So we're going to go ahead and select the Ethernet port here, and we'll start the capture process. And I'm going to plug the cable in from the PC to the Netgear, and we're going to see a series of packets come across. And they're, in this case, they're going to give a total of 7 packets. And I wanted to, we'll stop the capture at this point, and we'll go over these 7 and talk about what's going on here. Also, I wanted to, on the task manager over here, I wanted to select the Ethernet, and then we're going to do the view network details so that we can have a look at that and make some comparisons and see what I'm talking about here. Now, the first thing I want to point out is that during this whole process, if you look at this category here is the length of the how many bytes each of these packets have. So 42 bytes, 54 bytes, and if you add them all up here, you'll notice that they come up to 318. So it's when you look over here, you'll see that matches the number of bytes here. So it's a no discrepancy there. But the big thing I want you to recognize is the fact that it received 0 bytes. So none of the packets in here, none of these came from the switch itself. These are only one way out the PC announcements to the world, essentially. So that's a big thing to get in your head is that when they connect to the switch, they do that mechanical negotiation where it gets the link and establishes the link, and you see the lights come on and they lock in and they all green lights on the ports, and you can tell that there's something plugged in there. But that is not established through any packets, and that switch, the Netgear switch, actually has no intelligence to it at all, so to speak, that it would send a packet, because it doesn't really have a MAC address of its own, or even an IP address. Its trick is to try and appear like it's invisible, just like it was a crossover cable, and that the equipment, if it's doing its job the best, can't tell the difference between a crossover cable and the switch. So that's a big concept, and it's going to be very different when we go into the world of routers. And the thing about routers is that the routers are going to be both a router and a switch inside one, combined. And it's going to do both of these tricks where it's going to both appear to be invisible and yet also there when it needs to be. And that's something that, like I said, is all of these concepts that are very complex very quickly. So you don't want to kind of dive into those until you've exhausted all the simple stuff first. So let's just get back into this initial stretch here and see what we have. On this very first packet that got sent out, you'll notice that it's an ARP broadcast, and what it's doing, and it's called an ARP probe in this case, and what it's doing is it's being a respectful new person on a network. So what happened was it did the handshake with the switch. It got on. It saw that it was connected to a world of unknowns. Who knows where this switch is connected to? It could be connected to who knows what. And because we have a static IP address assigned, it needs to first find out if anyone else on this new network is claiming this IP address. Because if they're claiming it already, we can't use it. We can't get in here and say, hey, we want to share it, or we're taking it over. So it sends out this announcement, and what it's going to do is it's going to do this. It'll do this 3 times. So it'll say, hey, I'm making sure, does anyone have this IP address? And then finally, after the third one, when it gets no reply, it makes an announcement to everyone that says, hey, guess what? I'm taking over this IP address. I claim it for my own. And it does it twice. It just makes an announcement to broadcast all Fs to the whole group. And it talks about, that, hey, this is who I am, and I'm claiming this as my street name. So that's how it starts off. Because, like I said, it wants to be polite, and it doesn't want to come onto a new place that it has no idea who's there to do anything. And because we didn't give it a gateway or anything else like that, it's not going to try and reach out and say hello to anybody else. It's just going to do this simple, hey, I'm here and this is my name. Now, the next part here is the IGMP v3. This is something that's called when you look at the destination where it starts with this 224, this is what's going to be called a multicast packet. And this is one of these things, and it happens so much in the computer world. Is on the previous video where I talked about how the network interface card, the NIC, how it would only pay attention if something came with its individual MAC address here, or if it came in all Fs, like right here. But there's actually going to be an exception, and that exception is multicast. And so let me just get into multicast. It's a kind of completely different subject, and let's just go ahead and get into it, and because we're going to need it for telex equipment. I can tell you for the most part, the multicast is not a big thing unless you're a gamer or some other kind of computer nerd. But the mainstream, everyday office working type PC environment, you're not going to see that multicast very much. So, but let's go ahead and get into it, like I said, because we need it for telex, and go from there. So stand by for that. All right, so previously we talked about with the network interface card that when it's just sitting there listening, it's going to respond to two different types of inputs. It's going to respond to any packet coming in that has its MAC address in it. And we call that a unicast because it's going in one direction specifically toward that particular NIC. The other thing that it pays attention to are any incoming packets that start with all Fs. It's kind of a mandatory attention all type signal that it will listen to every time as well. This is a perfect example of when it comes to the computer and networking type world, that there's always exceptions to the rule, and this is one that applies here. And the exception is that there's actually three kinds of MAC addresses that it will pay attention to. Although the third one, which we're going to call multicast, it is optional whether you pay attention to it or not. And I'll go into that in a little bit. But basically, it's a way of communicating with a bunch of other computers at the same time without being obnoxious about it, like the broadcast is. When you put out a broadcast message, you force the attention of all the other computers on the system, and you don't give them a chance to opt out. And that also means that you fill up every single pipe in your local area network with that traffic. The switch doesn't get a chance to opt out of anything. So let's talk about how multicast came to be and what its purpose is. So if you're an individual person over here and you want to, let's say you want to share a video with everyone that's in your local area network, and you can't send it to, you can only send it one at a time. You can't send it to 5 people at one time because you only have one MAC address that you're sending it to, that's your intended target. So you don't want to use the broadcast, because if you use the broadcast, you hijack all of these lines and you force everyone to watch the video. So they wanted to come up with a way to where you could share something with multiple people at the same time, but also that those people could opt out. And they say, no, thank you. We don't want to participate in your multicast. So they came up with this entire system of being able to weed out the multicasts that aren't wanted and essentially subscribe to the ones that you do want. And this has everything to do with the type of switch or router that you have and whether it can handle such requests. Now, we're dealing, in our case, with an extremely simple switch here, and it has no kind of those rules that it can refer to, no intelligence to make those kind of calls, no programming to set up. So basically, if you have a simple switch, it's going to take every multicast broadcast and treat it like it's a real broadcast with all Fs, because it just doesn't know any better. It can't take the risk that the person on the other end wasn't looking to get this transmission, so it goes ahead and puts it through. Now, multicast can be an IT person's nightmare, simply because every time you go to use it, you clog up traffic everywhere with this information. So in the modern world now, they found that this really isn't a reality. You don't have offices around where people are trying to share broadcast stuff to the other people. They all are in their own little world anyway, and this isn't really a big thing. So now it just so happens when it comes to the radio world, this is where you're going to have a radio here, and it's going to use the multicast to spread out the radio traffic all over. That way you could have a console anywhere out here, and it's sure to get it. And because the bandwidth that the radio over internet protocol uses is so small, it's tiny. It's just like an internet telephone, a VoIP phone. It's like 60K of bandwidth. So it's like a little trickle fly to the modern switch router system. So it doesn't really care about that. It's only when you get in trouble with multicast is when you're trying to stream stuff like video. So, but that's the multicast introduction. And what you'll see is that for every multicast packet that's sent out, that the first three numbers in the ID here, 01005E, that's what lets the switch know that, hey, I'm a multicast packet. So if we came over here and we look at on the Wireshark, and we look at the IGMP membership report here, if you look down here at the destination, you'll see that the MAC address that's being sent to everyone is 01005E, and they call it MCAS 16 here. 16, and you notice in the up here, it corresponds to this the actual IP address. So there's a relationship between the two of what the MAC is and what the IP address is. But anyway, the first three numbers here are the ones that show you what's going on. That it's a multicast, and you can see here in this case it's using the IP address of 224.0022. And what this is putting out is that it's letting the system know to this is where you would want to get in and say, hey, I don't want to participate in this, or I do want to participate in this. And it's a crazy kind of like almost forgotten world, if you will, unless you happen to be in this little gamer thing. I think they get into that a lot. But for your just normal average office worker, this is non-existent. So, all right. Well, in the next videos, we're going to get into the telex side, and we'll look at the multicast there and the use of ports. So, all right. I hope this helps, and we'll talk to you soon.